Hi, everyone. Welcome to Rieck's Lunch and Learn series. My name is Caroline Griffin. I am Director of Operations for the Rieck organization, and I am super excited to have John Petitte and Paulo Rieck from Amplifi Labs here today to talk about serverless. The future is wow. Before we get started, just a couple of quick reminders. This presentation is being recorded. It will be posted to Rieck's YouTube channel and then shared via the meetup group where you registered. Please do keep yourself muted throughout the event. If you have any questions, put those in the chat box. John and Paulo will be taking questions throughout the presentation, so it'll be pretty interactive. And then the last reminder is that the best way to view this presentation is in speaker view. That will give you a nice big presentation on the left and the speaker on a small box on the right. Without further ado, I will hand it over to John and Paulo. Thanks for being with us, guys.
Thank you very much, Caroline, and welcome everyone. I see some friends in the audience here and some friendly faces. So welcome to all of you, all those that I know, and welcome to those that I haven't met yet. So today we're going to be talking about serverless, and we say that the future is wow, because it's not just now, but this is the first time where we're seeing a real opportunity for serverless to do some interesting, awesome, complete solutions, and we're really excited to talk about those with you today. I am John Petitte, co-founder and CEO of Amplifi Labs, and I'm here with Paulo Rieck, co-founder and CTO of Amplifi Labs, and we will both be presenting different things. Paulo will have the demo today, and I will be talking about serverless in general.
Hello, everyone.
So just in general, who are we? Who are Amplifi Labs? We are a software development shop in general, but our people are composed of fractional CTOs, an application development team, AI and ML team, UI UX team, as well as a staff augmentation program. And what we do, and all of this provides the perspective of that we currently have on serverless, right? This is why we interact with serverless. We're long-term partners in everything that we build for everyone, everything that we do, everyone that we interact with. We design applications, we build software, we architect solutions, we provide staff augmentation. We'll also help with international localization in many circumstances, and in some cases, we invest in our customers as well. So all of those things have come together to give us what we think is a good perspective on why serverless is important for various types of users across research, startups, corporations, etc. So we're going to talk about what it is not, why you should be interested in serverless, who should be considering it, the ecosystem. So what are the different options that are out there? How do you select from those options? What are pitfalls that you should be aware of when selecting those options? And then we'll examine a real world example. So exploring serverless, who, what, and why. Let's take a look at the what first. So what is it? And we say typically, okay? What is serverless typically? So we can start with the good old Wikipedia definition, which is probably maintained fairly well, since developers are probably the ones maintaining it. Serverless, according to Wikipedia, is a cloud computing execution model in which the cloud provider allocates machine resources on demand, taking care of the servers on behalf of their customers and eliminating the need for server software and hardware management by the developer. Now, that's a very broad definition, and we aren't totally on board with that as narrowing it down close enough, because we think that some services that exist out there can fall into that definition, which we don't consider serverless. So the key concepts that we think that definition, some of the key concepts that we think that definition misses are on-demand cost structure, as well as elastic scaling. And those are very important to us in our definition of serverless and what we typically consider serverless. But it's important to understand and note that the definition is evolving, and it evolves based on new products that are presented. It evolves based on existing products that change pricing structure or their offerings. And it evolves based on what the open source community is doing, right? So because of the speed of evolution of what is, you could consider the serverless ecosystem, when you chat with some folks versus other folks, you're going to find that their definitions of what they consider to be serverless slightly different. For example, Heroku, some people might consider Heroku, many of the services that Heroku provides as serverless. We do not. We think it's close. We think it's on the edge, but we don't actually see it that way. So let's dig a little bit deeper into what serverless is. So from a management standpoint, this is sort of where the crux of serverless is coming from, I would say, is that it's eliminating overhead. It's eliminating the things that a developer has to do and get in there and manage. So when we talk about management, we're talking about capacity planning, configuration, management in general, maintenance, fault tolerance, and scaling. And so you're going to see those sorts of issues around container VM and physical servers. And when we eliminate those issues, that's where the concept of serverless came from, because you're separating yourself, you're abstracting yourself from that layer, containers, VMs, and physical servers. And at the same time, you're attempting to eliminate the management required around those different pieces in the layer. You also have an execution model that can help define serverless. So it's going to be ephemeral, which means that something, for example, something will execute and then it's gone. You no longer control it. Those resources that were used to execute what you need are now given to another customer, another person, another party, whoever that may be. That also means that there's no memory that is sustained between executions, right? The memory is ephemeral, just like the entire execution context is ephemeral, and it's elastic. So because each execution exists and then disappears, you can elastically scale the number of executions seamlessly. And that's a key part of what we consider serverless as well. Cost is a big one. So again, it's thinking in terms of execution. So cost is going to be execution based. So if you have 1,000 executions, you're going to pay for 1,000 executions. If you have no executions, you're usually going to pay nothing. And this is in contrast to, let's say, reserving a virtual machine for an entire month. You're paying for every hour that you have it reserved that month, whether or not you're executing something on that virtual machine or not. This one is a little bit more vague. So simple connections, but the simplicity is a key qualitative thumb in the air test that we have when we're considering something serverless or not. So simplicity, right? So I have one serverless service and it's simple to connect it to something else, right? Managing virtual machines, containers, or physical hardware, that management is not simple. It's painful. It takes a lot of time. But serverless offerings are typically, because they're simplified, it's also simple to connect them to something else. So for example, Lambda functions and simple queue service in AWS, very simple to connect those two. Auth0 and Hasura, those are actually two different products from two different companies, but it's very simple to connect the two. Those connections can be API based, or they may not be API based, maybe abstracted away. Tutorials. There's a tutorial showing you how to connect two different services together. Generally it's probably going to be simple. That's a good sign that what you're looking at is a serverless offering. And just to reiterate, like, this is the important part. Simplicity is the key. If you're getting into something and it feels complex and you're slogging through things, most likely that's not going to be serverless. It hurts me a little bit as a developer to be this vague, but the feeling of simplicity is very important with these types of products. Deployment. So not just connecting things, but deploying your code. It should be simple. It should be my thumb in the air is, can we get something set up can we get it set up in the way we want to in like less than 30 minutes, something like that. So the deployment pipeline, all the way from development, staging to production, should be easy, it should be simple, it shouldn't be painful. And then executing tests along that pipeline should be the same way. This is another litmus test for whether or not a service is actually serverless. Setting up, just like deployment, which is, setup is usually a part of deployment, but it's not necessarily a part of deployment. But generally setting up, getting going, putting something out there that's functioning for the first time, that needs to be simple as well. I'm thinking under 30 minutes. And again, there's probably a tutorial around how to do this. That's very straightforward. It doesn't take hours of documentation that need to be read through. And there's minimal configuration, right? Things just work. That's sort of a key part of serverless. They don't always just work. There are times when, we'll talk about a little bit later, when mistakes that you can avoid that prevent things from being painful, but we'll dig into that.
And just to add one thing, John, so you can build really complex things by connecting simple pieces of software. So when we talk about simplicity, that is what we mean, right? Not necessarily building simple things, but simple pieces that connecting produces something great.
Yeah, that's a great point. So simplicity in what we're describing here does not mean that the only types of solutions you can build are simple. It's the simple building blocks that you can create really great complex things from. So what is it not? What are some, we've already reviewed some things to keep an eye out for that might trigger in your mind that it's not serverless. So if you're configuring virtual machines, obviously it's not serverless. If you're, working with container orchestrators like Kubernetes, if you're managing those sorts of things, those are not serverless. You're not in the serverless world, but you can have, say, this might be common in a corporate environment more than a startup. Let's say you've got a Kubernetes team and they have a cluster of containers in Kubernetes, and they have a team that orchestrates and manages that. Well, they might deploy a serverless service in their cluster that another team then interacts with in a serverless way, right? So you might have one team that manages that stuff and then another team that operates in a completely serverless world. If you're managing scaling, and this is one reason why we, I'm not picking on Heroku, we use Heroku a lot, but this is one reason why we don't consider in our business Heroku to be serverless, is because the scaling management there is not complex, but it's not automatic in a simple way. And then if you're being charged for reserved resources, then that's another indicator that it's most likely not serverless. Now, some products out there charge in step functions, right? Rather than reserved resources. And that's sort of a fuzzy line between whether or not you would consider that serverless or not. But if you are, if you see that you are literally paying for, I'm reserving this resource, that's probably a good sign that it's not in the world of serverless. So why even consider serverless? So cost is a big one. That's actually what first interested me when I started looking at serverless, probably back in 2016 or something like that. The fascinating thing that I saw were AWS Lambda functions, and the fact that I didn't have to pay for server time or pay for Azure's, I forget what their product was called, but it was like web. Maybe it was just called web app at that time, right? You had to pay a certain amount continuously every month. You reserved those resources. And then AWS came out with Lambda functions, and you only paid when they were executed. And that was awesome from a startup perspective, because while you were working on things and you had no users, you were paying nothing, and every dollar mattered at that time. Security. So managing infrastructure like VMs, containers, Kubernetes, or physical hardware, the security around that is hard. It's very hard and it's complex. And there's a good chance that the serverless provider of the product that you're using their dedicated team, where all that they're concerned about is the security of their hardware and their infrastructure, chances are they're much better at it than you will be. And so if you can offload that security to experts, that's a huge win, especially if you're a small team. Productivity, this is another huge one, right? To get going from 0 to 60 as quickly as possible by eliminating the things that are not core value adds to what you are trying to do at that moment. That's huge. And scaling is another really awesome one. And it goes back to the cost, right? The beauty about scaling here is that you have some trade-offs, which we'll talk about later, but theoretically, you can scale as large as you want. There are some usually hidden caps on what you can scale to, but getting beyond that is actually relatively simple. You just contact the service provider and you say, hey, look, our volume's going up. You need to make sure that you can handle it. Then they will make sure that their internal resources can handle it. They're usually pretty prepared for that. And then everything's good to go, right? And most likely, you're never even going to hit that point. So scaling just happens automatically, and it's elegant and it's beautiful. Instances where serverless is probably not going to work. So cost actually is another one. Just like it can be a benefit for serverless, it can be a detriment to serverless. An example would be if you're running Lambda functions 24/7, 365, and it's a constant volume or a relatively constant volume of Lambda functions. Most likely, it is going to be much more cost effective to reserve virtual machine time 24/7 for the month and just run everything on there. Security could be a reason not to use it if you need specific requirements in security that you know the vendor doesn't provide, which usually means that the vendor doesn't demonstrate that they do provide it. So one example would be, let's say, Azure with one of their products, they don't describe a recommended way to use that product for HIPAA regulated data. If they don't do that, then chances are their product is not going to be appropriate from a security standpoint for HIPAA regulated data. And then lastly, functionality. Because serverless adds simplicity, it eliminates some flexibility, which means that there are things that it will just not be able to do that you may want it to do. And you will not be able to get it to do those things. And so you will have no choice. You cannot use that product. In short, everyone should be considering it. Doesn't mean that everyone should use it, but everyone should be considering it. So for startups, it's almost always a huge win because of cost and productivity. For corporations, cost doesn't really matter as much, but productivity can be a really great thing here because, let's say that your Kubernetes team sets up an internal serverless product. Well, all your other teams that use that product shouldn't really have to interact with your infrastructure team, right? Your infrastructure team sets it up and everybody else just uses it, rather than your infrastructure team being a part of every discussion for every new product that you're trying to build, internal or externally. Researchers, it's going to be cost, and cost is probably going to be a huge driver for this one. You, as a researcher, you're probably not running loads 24/7, 365. Maybe you're going to run them, every couple of days or whatever, depending on what you're doing. That's a big win when you only get charged for the time that you're actually using. Finance, there are options out there for finance. Healthcare, there are options out there for healthcare, right? There are serverless and service providers and products that are specifically designed for those types of regulated environments, as well as ones that are prepared to handle it. And governments in the same way. So this is a little bit redundant, but literally no one should not be considering this. But it doesn't mean that it's going to work for everyone, as we've seen, and we'll discuss some pitfalls that we'll want to avoid And if they can't be avoided, then serverless won't make sense, right? But everyone should at least be looking at it and evaluating whether or not it makes sense. Let's take a look at the ecosystem. And there are a number of dimensions to this ecosystem. We'll first look at serverless functions to just give an idea and to give you a concept of the breadth of the scope of the ecosystem, because it's much too large for us to go into depth into right now. So in a 15-minute search, approximately, when I was looking up the current state of serverless function providers, I found something like, I think this is 15 different serverless function providers. So it's 15 in 15 minutes. All right. Now, these are just some ideas of the different types of serverless products that are out there. So front-end delivery, API exposure, databases, authentication, authorization, notifications, email, the list goes on, and this is not even an exhaustive list. So let's be conservative and say that it's 15 different options for each of these specific needs. Now we're looking at a huge volume of different serverless products that have to be sifted through. This is good in the sense that you're probably going to find a product that works for you. It's going to fit your use case. It's bad in the same way that JavaScript fatigue is bad, where JavaScript is so popular, it's so ubiquitous that sifting through your options of how to accomplish something becomes crippling. It's like the cereal aisle. So there's a real challenge there, but the fact that this challenge exists is the whole reason why we're having this conversation today, because the options allow you to create complete solutions using serverless offerings. When you go to implement serverless, the first thing that you really need to think about, you really need to understand well, is what do you need to accomplish from a business standpoint, and then from a product standpoint. You need to understand it in detail. You need to understand it in concept, because you're going to carve this solution, this plan up into pieces. And these pieces are what you're going to look for serverless products to create the piece inside, right? So for example, do you need a WebSocket? Do you need a document store? Do you need a SQL database? Each of those is going to be a different serverless product. Do the different pieces of the application or serverless products need to be protected behind authentication and authorization? If so, is it behind a user authentication and authorization, like a customer, or is it just behind a server authorization and authentication? Do you have language restrictions or package restrictions for a specific product? So let's say serverless functions. For some function providers, you won't be able to use C-based packages in a Node.js, a JavaScript environment, right? So
especially if you need to compile C packages, right?
Yeah, especially if you need to compile those packages. And this could be one example where this could be very important, is in image or video processing, which you frequently find low-level packages. So if you're doing image or video processing in a serverless function, that's your goal, you need to make sure that the provider will support that. Not all of them will. Once you have your architecture and once you know what you want to do, then you need to evaluate each serverless product that you could potentially use with your architecture as the guide. So what's the cost today and what's the cost tomorrow? A lot of serverless products have free tiers. And so it sort of looks like there's a very cheap phase, there's a relatively expensive phase, and then it gets cheap again as you begin to scale up. So understanding those humps is very important. Resource limits. Is there a resource limit on execution time? Is there a resource limit on memory? Is there a resource limit on, so RAM, right, versus your hard disk memory or something like that? So you have to understand what the restrictions are on that product that you have to operate inside. And then you need to see if that's going to fit in your architecture. Performance, such as cold starts. So if you need a response, let's say you need a product, a specific part of your application that you think could be serverless. You need a communication, dead time between that and something else of 2 milliseconds. Let's say that's what you need, 2 milliseconds. Well, if there's a cold start, right, the time when the company that owns the serverless product, right, if there's a time of 10 seconds that they need in order to allocate resources to you before it'll execute, obviously 2 milliseconds is not going to work. It's going to be a minimum of 10 seconds. So you can't use that product. You can't use that service. Portability and vendor lock-in. This can be important for many different types of businesses. What's the probability that you will have to switch to a different vendor? Move your code. Let's say you have code that executes X, Y, or Z on a serverless product. What's the probability that you're going to have to move that from one vendor to another? And then what would be the consequences of that? How painful would that be? It's important to understand because it happens. There are absolutely times where you need to switch. Understanding the vendor's happy place is a very, 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 very important part of selecting a solution. And you'll most likely hear this mentioned again later. The happy place is what the product wants you to be doing. And there are almost always tutorials set up that outline the happy place of that serverless product. If you move beyond that happy place, pain usually follows very closely behind. So make sure that you understand the happy place. If there's a tutorial showing how to do it, that is awesome. You're most likely in a safe zone. Monitoring and debugging is also very important because there will be a time when you need to figure out why something isn't working always. And do they have a good, effective, simple, easy, clean way for you to do that? Or if it's not all of those things, is it at least acceptable? And security, which we've mentioned before, but before you build something in a serverless product, you want to make sure that there's a white paper or there is at least an official guidance provided by that product that says for this specific regulatory environment, we recommend you use the product like X, Y, or Z, or the product as is acceptable to be used. Because again, if you get in there, you build it, and then somebody asks you, well, does this product, how do you know that it's acceptable for use with medical information? And an acceptable answer is not, I'm sure it's okay, or I don't know, right? You're either going to have to find out an answer, or you have to assume that it's not acceptable and then move your code somewhere else. Avoiding pitfalls. So again, number one thing, stay in the happy place of the product. If a tutorial exists, you know you are smack dab within the happy place of the product. If a tutorial does not exist, then you absolutely should build a proof of concept to demonstrate to yourself that the serverless offering that you want to use can support what you need it to do. If you do not do that, that is a huge, huge, huge risk. And I say that from experience. Everyone in our company has probably had an instance where they were playing around with something, right? And you hit a point where you're like, oh man, this doesn't do that. Wow, that's good to know, right? And you want to hit that before you've, written a ton of other code. In order to prepare for that, again, we're going back to building a detailed plan / architecture. That's your roadmap that tells you what you need. That's your guide through this entire process of assessing whether or not something is going to be the right solution for what you're doing. And it is a critical part of proving to yourself that that the product you want to use can support what you want to do. A part of that plan is organizing all of the different products and non-serverless products and strategies that you want to use. So deploying so serverless is very much in the avenue of microservices. They're not identical, they're not the exact same thing, but there's overlap in between. And deployment strategies for microservices are very important. So when you have different pieces of the application that are all built separately that need to work together, you have to have a plan to make sure that when you're deploying to one serverless product, how is it going to affect another serverless product? Do you need to deploy them all at once? How are you organizing and managing all the different pieces so that they work together very nicely and you don't introduce breaking bugs in one when you are updating another one? And then synchronous versus asynchronous workloads. This one is tricky, but it goes along with the fact that most serverless products are asynchronous, which is what allows them to elastically expand theoretically infinitely as far as we're concerned as a business. So that means that if you need certain things to happen sequentially one after another, you have to very intentionally design the system so that those things happen one after another, guaranteed. All right, Mr. Rieck is now going to give an example of a real-world implementation.
Okay, we'll stop presenting, John.
Yes, one moment. There we go.
All right. Just let me know if you can see my screen.
Yep, looks good.
Okay, perfect. Thank you very much, John. So the real world application which we'll talk about is Keepsake Tales, and I'm really happy to see some friends that I know through Keepsake Tales, right? So it's great to see you. So Keepsake Tales is a children's custom book generator, right? So people are basically able to create a character and for kids, right? So let's say for children in general, and they are able to select, for example, hair, type of body, type of face, skin tone, things like that, and submit the order and receive the book with the custom character and with the custom names inside the book, right? So it goes directly to your home. I would just show how it works really quickly here, because I want to make sure that everyone understands the concepts here. So basically, this is the website. So I will just create a character. I can submit a picture. I will not do this right now. I will just start without a photo.
So if Paulo had submitted a picture, then the picture would be transmitted to a machine learning algorithm that is a serverless product. Mm-hmm. And the machine learning algorithm would return the customized character that you're going to see in this next phase.
Yeah, absolutely. And we will see how the serverless integration works for also the AI part in a few minutes. So I will just add my daughter here. She's called Esther. I will configure how she looks pretty quickly here. So she likes this type of hair. She's blonde, and she looks pretty similar to her, right? So I just approve the character. I will click in a book, and now I am able to see a preview, right? So on the website, I can check how the book will look like, right? And if I submitted an order, I will receive the book in my home. That's how it works. All right. returning to the presentation. So why did we choose to use serverless? So the amount of processing to generate the printable files is considerable. So the printable files are generated and sent to a printing partner, right? And those files has literally hundreds of megabytes because they are pretty high quality. And to generate like all the individual pages for the books, this is CPU costly, right? So it's a great idea to do this in serverless in parallel. We will talk more about this really soon. So we need to be prepared to produce hundreds of books simultaneously, right? So we tested with 200 books simultaneously, and we were able to do this using serverless. For each individual book, we need to process dozens of pages simultaneously as well, so, right? So distribution is crucial in this project. And talking more technically, we as a dev shop, we are serverless provider agnostic. So we use AWS, we use Azure, we use different solutions. We use different programming languages, but we really do like to work with Node.js, TypeScript, right? So this is our bread and butter, and everyone knows how it is hard to, so Node.js is single thread, right? So how we scale a single thread application, right? So the answer is also working with parallelism, or in other words, processing many times in different services at the same time, right? Also, we need asynchronous coordination, and we use queues for that. And this is also an important piece of this project. We also need reconciliation mechanisms. We have two actually. So if something goes wrong, and to be honest with you, it can sometimes go wrong, right? So we have mechanisms to detect failures and recover from that. So this is also easier to implement serverless. Also, we needed a scalable and solid serverless AI implementation. And we use serverless in this case as well. And as this is a startup, costs really matters, right?
And the cool part here is, Paulo says the costs matter. And the beautiful thing is that the costs of the implementation as it is right now are incredibly low. They're virtually negligible right now for having a system that is prepared to scale almost infinitely, which is absolutely fantastic.
Yeah. So what we achieved by using serverless, so we are being able to produce books in average in less than 1 minute. So you know what that means in terms of costs, right? So just reinforcing what John just mentioned. I already mentioned that we were able to test the production of 200 books. So the funny thing is that we didn't reach the limits on the serverless provider to produce even more books simultaneously, but we were not able to create that many orders in our computers at the same time. So despite producing the books, right, we also have some other pieces of software. So for example, we have the functions to submit the books and do some pre-processing on the API. So we do way more using serverless than just producing the books. We were able to implement a fully scalable AI service, right? So we are being able to submit pictures, many at the same time, and consistently returning results in terms of hair type, hair color, skin tone, right? Really fast and it's scalable. Also, we used all the content that we produce, and some part of the content that is consumed on the front end comes also from serverless functions, from serverless products, right? And all the content that we generate, for example, are being stored on protected data lakes for all the binary files that we send to the printing partner. Also in the front end, we are using Vercel, which is also a serverless solution, right? So, and it is great because it also implements automatically globally distributed CDN, right? So, and we didn't write any line of code. We didn't configure any external service for that. So this is great. So how did we achieve that? So as John mentioned before, it is like mandatory to have a good plan prior to start coding things on serverless. And some people here knows that this is totally true. We spent a long time thinking about things. And when we started to implement, things were really smoothly, right? So things seemed even easy because we took the right time to think about all the possibilities. And we even think about things like how to expand the system in the future, how to add more, let's say, capabilities in terms of adding accessories or different hairstyles, right? So we know that we are able to do this in the future. And also it is important to mention that we used a framework called serverless framework. So it really helps us to make all the deployments, right? So you can configure CI/CD, for example, using serverless framework. And the greatest aspect of this, so John mentioned that he started using Lambdas on AWS in 2016. And I can imagine the pain, which is, I went through this as well, but it is really painful to write code for serverless in Lambda in AWS, for example. This is just one example, okay? So it is really hard to do this if you don't have a framework. So each function is treated individually. It seems that there is no connection in code, and serverless framework allows us to code as a regular monolithic software, but it produces a full distributed software in terms of splitting all the software into different functions in the service provider, Azure, AWS, whatever. Is it clear, John?
Yeah, I mean, the beautiful thing here that I think you probably internalized is that you can deploy it as monolithic, but it operates like microservices, exactly, which is just awesome. It's like taking the best of both worlds.
Correct. Yes. All right. So just briefly, which tools we selected for that. So we are using Vercel. We are using AWS for a lot of things. For AI, we are not. And this is worth to mention that there is nothing wrong mixing different service providers if if there are specialized in one thing or another thing, right? So we decided to not use AI on the AWS because there is a better solution, right? And so we are using AWS for the API gateway to expose a REST API. We use SQS to manage the queues, Lambdas for the processing, S3 for the data lake, CloudFront as well for the CDN to expose all the content for the books to generate the previews in the front end, right? And the AI, as I mentioned, is in a different service provider. So I think that everyone is tired now, but just 2 diagrams. I promise I will move faster on that, but just to give you the sense on how it works, right? So in a higher level. So for example, for the process of submitting pictures and getting the characteristics for the kit, the user in the front end submits the picture. It sends a request to the AWS API gateway. It saves content on data lake. So the binary file, the picture itself, the JPEG or GIF file, whatever, is saved on the data lake in a protected way. So after this is done, there is another function that returns the signed URL to the front, and the front end sends the URL to be processed on Azure AI. So, and after this, the AI's the picture is processed in the AI provider. We return all the characteristics for the kit, and the character is automatically created on front end based on the kit's characteristics. And finally, about the process to submitting books. So on the front end, the user builds a character, user starts the purchasing process. So it then goes to the shopping API, which is another serverless provider. So the user generates the order, shopping API through a webhook makes a request to our API gateway running on AWS. We do some pre-processing validations. We put all the jobs in a queue, right? The queue manages the load, right, of functions being run simultaneously. If there is room to add more books, it just adds. So the next step is generate the book files, the binary files to be sent to the data lake, which is in this case a AWS S3. Oops. We submit the orders for printing, for the printing provider. And also we have two reconciliation mechanisms here to detect failures before producing the binary files for the books, and also before, if anything went wrong while submitting the books to the printer service, right? So this is everything that we do in serverless in a higher level. Do you have anything to add here, John?
Nope, looks good.
Okay, so this is the end of the presentation. Thank you very much, everyone. And if you have questions, please let us know.
Thanks so much, Paulo. Thank you, John. Yeah, I don't see any questions in the chat box. You guys were super thorough, but anyone, please feel free to unmute yourselves, ask some questions. I thought it was great. I really love the keepsake tails example. That's so cool. All right. It looks like
I have a question.
Oh, awesome. Yes, go ahead.
First of all, thank you for the presentation. Really, really nice. Lots of details. Now, what do you do if let's say you have some complex application where you have a lot of Lambda functions, right? That do all kind of different things. How do you manage those? Normally with like a REST API application where you have multiple endpoints doing all kind of things, they're traditionally in one single project that is managed. But what do you do if you decide to break that down into Lambda functions and you want to manage the code base in an efficient way? Well, are there any solutions to that?
Yeah, so my first advice would be to use a framework like serverless framework. So you can reuse most part of your code, your existing code, right? And so just thinking about a project structure, let's say in the old way, let's say you have controllers, you have the DAOs, whatever, right? So you just need to change, in this case, you just need to change your controllers and replace with something on serverless framework, and you'll still have, will be able to migrate your project to a serverless infrastructure, not change it that much on your logics on your application, right? So that would be my first advice. Otherwise,
Yeah, I mean, you loved working with serverless framework because out of the box, it gave you some interesting things like the ability to group functions and different tasks together, right? So different API endpoints, like let's say you have, one team and they have one specific project, one thing that they're working on. And from a business standpoint, you feel like that's going to be an isolated set of tasks that you're trying to accomplish. You can isolate that into a serverless framework implementation. And then you get the ability to, by using serverless framework, deploy to staging and production. So you can switch those environments during the deploy. So, Sebastian, to me, it's using a framework like serverless framework, which we just happen to like. It gives you that really nice ability to divide things up, based on your team or based on your product or based on whatever you want. Does that make sense?
Yeah, so basically, I can group a collection of those functions into one single project, even though they are independent from each other, right? There is no direct relationship between them. I can just put them in one single Git project of some sorts, and then make use of the serverless framework to manage those and deploy them and so on, right? And follow the same development cycles that you would do with a normal project.
Correct, that's correct. And also, so you can actually, let's say there is some piece of code that you reuse a lot in your code. So you can just establish a service function where you can call from anywhere in your code and use it, right? So
right.
It looks like it gives you the ability to work as a normal project, but deploying in a serverless provider. That's it.
Awesome. Thank you very much. Really good job, guys. Thank you.
Sure. You're welcome.
Thank you.
Great question. Leave it open for just another minute for any other questions.
Sure.
John, Paulo, if people have any additional questions that they think of afterwards, I know you had your email addresses up there. Is that the best way to reach you all?
Yeah. Yep. You can reach out to us via email, or our contact info is on our website as well. Feel free to reach out on LinkedIn. We're both on there. We both respond pretty regularly. So that's a great way as well.
Awesome. And I'll just remind everyone that this presentation is being recorded. It will be posted to Rieck's YouTube channel and then shared out on the meetup group where you registered. We do have 2 lunch and learns left this year, 2 next week, one in Wilson on Monday with Greenstream, and then virtually on Wednesday with CalChip Connect. So please attend those if you're able. John, Paulo, wonderful presentation. Thanks again, guys. We appreciate you joining us and for being a sponsor of Riot.
Yeah, you're welcome. Thanks for having us. Thanks, everybody.
Thank you.
Awesome. Thanks, y'all. Bye.
Bye.